Hello everyone, welcome back to our channel. So today we would be discussing the recent Codeforces contest that happened today. So I would be discussing the solutions for the problems. I was managed to solve 4 of them, so we'll be discussing A, B, C, D. Okay, so let's jump to the first problem. So the first problem was very easy for this Codeforces contest. So here was the problem was saying that y mod x is equals to 0 and we need to find some z which is between x and y such that z is divisible by x but y is not divisible by z. Okay, so if we jump to the logic part, like how would this problem would have been. So the question is given that y mod x is equal to 0, right, and we need to find some z which is z is something like this, or like it could be equal. I'm not sure if it is, yeah, so it is not equal, so it's just between them. Okay, yeah, so it's between them, and there is a condition that x mod z should be equal to 0 and y mod z should not be equal to 0. So we know that y modulo x is equal to 0, so y and also y is greater than x. So we know that y would something be x, 2x, 3x, or like till nx kind of a thing, like till infinity I would say, or like 10 raised to power 18, anything you can say the final. So y would something be a multiple of x, right? And if we talk about z also, z would also be some multiple of x, right? Because it is also divisible, right? And it is not then divisible by y also. Okay, so for that to happen, now let's try to think. There could only be a one condition when y is equals to x or y equal to 2x. Then only I can say there won't be any z that is between x and y that would be divisible by x and not divisible by y. Now let's see why is that. So let's suppose y is equals to x. Okay, so if y is equals to x, there is no space between x and y, so z cannot be possible. One is this thing. Now if y is equals to 2x, right, so z would be in the range of from x to 2x, right. In between the range of x to 2x, there won't be any z for which this could be divisible by x. Why is that? Because the range would be from x plus 1 till 2x minus 1, and I cannot find any value between those z for which it would be divisible by x. So in that particular case is also false. Now let's assume when y is greater than equal to 3x. Okay, if that is the case, then the range of z would belongs to x to 3x, right, or like greater. In that case, I would always be able to find some z equals to 2x or some value greater than equal to 2x for which it would be divisible by x, like it would be divisible by x, but it won't be divisible by y, right. So if I show you the code of this, so it would be a very simple code. So simply we have taken x and y as the input. If y by x is equal to 1 or y by x equal to 2, then only case my answer would be no, else my answer would be yes. So this is how the problem is. I'm sure everyone was able to solve this problem, right? Let's jump to the second problem. Okay, so this was also an very easy problem, right? Let's understand what the problem statement is saying and then we'll discuss the solution. So let's call a string t alternating. For this is for the ti not equal to ti plus 1. Okay, and we are given with operations and it at most 1. You may perform the following operations on it at most once. Okay, choose a substring. Okay, alter it from a to b or from b to a. Okay, and then reverse the chosen substring. Okay, and this is the test example that also given, and you need to focus on this line. However, you always have to perform third step in the operation. Okay. Okay, so let me explain you with the problem statement. So the problem, let's take an example, a double b aba. Okay, so a double b, let's not take this example, let's take this particular example, aba double b ab, aba double b ab. Let's suppose this is your string s. Yeah, right, let's suppose this is your string s. Now what the problem statement is saying? Problem statement is saying we need to find an alternating string. We need to make an alternating string. What do we mean by alternating string? Alternating string would be that t of I should not be equal to t of I plus 1, right? So either it would be AB, 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 or it would be BA, 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 this kind of a, only these two alternating strings would be possible, right? Just try to think why this two would only be possible, because as we have two characters, right, and at the first index I'm having two options, right? Either it could be A or it could be B, but for next option I'm still left with only a single option, and then so far and so forth. So only I would say there is two possible options that I could say, that either the string would be AB, 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 or it would be BA, 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 BA. So what we can do is, now the problem statement is saying they have defined an operation. Now what do they mean by an operation? They mean by that, let's suppose we take this particular substring, right? When we take this particular substring BAB, we have to perform, we can either do ABA, like alter this particular string, like change B to A and A to B, and then reverse it. So reverse would also be same, or we could not alter the string, just simply reverse it, right? So by the combination of these two, what our string would be ABAB. So adding, if I have done this particular operation, my string would have been ABAB, ABA, and if I have done this particular operation, my string would have been ABAB, BAB. Just ABAB, ABAB, BAB, right? So now I know that this particular string is an alternating string, so I would simply output yes. And if this cannot be possible, I would simply output no. Now I'm sure that with the discussion of this particular thought only, you have come up with the approach that how we are actually, like, how would be solving this problem. Now let me give you a simple idea. Like the first thing that you have to visualize from this problem is only these two particular alternating strings could be possible, right? Now for a particular string S, for any given string, we'll first assume, let's suppose I want to make this particular alternating string, right? Let's suppose I want to make this particular alternating string of length n, right? Now to make this particular alternating string, how can I make it? First I need to find a substring. A substring where the like from L to R, where the characters are not same. So let's suppose my initial S is, let's take this particular example, A double B A B A. Let's assume that my string that I want to form is A B A B A B. Now if I take my substring length, like this is the first character where it's different, so I'll assume as to be my L, and here is the last character where, like till here, like from the back the first character is R, like where they are different. So my substring length which I am taking would be BA BA, right? And I want to make it to AB AB. Now we'll check whether I can form this to this. Now we have the following operations that we can perform. The following operations that involve, first operation we could do is, first kind of thing we could like reverse these characters, AB AB, reverse as in B to A and A to B, and then reverse it, the whole substring, or simply just reverse it, AB AB. So I know that I am able to achieve this AB AB kind of a thing, so and this is equal to this, so I can say that the answer would be yes. Now let's suppose like in the similar test case only, I'll discuss the next also, AB AB A. Sorry, let's take the string as to be, the string is this one, yeah, the string was, string S is equals to A double B A B A, yeah. Now let's suppose I have to make this A B A B A B A 3, okay 6, yeah. So my L would start from here, right, and my R will go till here. So I would have taken this particular substring, right? Now when I would have taken this particular substring, I'm having ABB and I want to convert it to BAB. Now I'll check whether this is possible or not. Like I'm discussing the second case, like it could be this or this, so whichever gives you the answer, it would be true. Like we have got the answer as to be yes, but just from the clarification point of view, I'll just tell you that how we are solving for this as well. So AB A double B, so first alter the characters this and then reverse it, double AB, and here simply reverse the characters double BA. So for both of the strings, I'm not able to achieve BAB. So I can say that this particular alternating string is not possible. Only this kind of alternating string is possible. So my answer would be yes. Sometimes it could be that this is not possible, this would be possible, then also my answer would be yes. So I'll show you the code as well. Like in the contest, I've not written the optimized code, I've just written all of the possible use cases that are coming to my mind. So what we have done is simply, like, I have make two different alternating strings, S1 and S2 here, and I've considered L and R, the two pointers for the substring. I've found for L, I have found for R, right? Then I've in this particular part, I'm matching the particular strings, right? So temp, I have made the string, this is my temp string, this is my temp string, and this is my original string. And this string I am making, the string that I am making is rev original, right? So this is my rev original, rev temp kind of thing. Yeah, rev temp, not rev original, it would be something rev temp. And then I'm just comparing all of the strings. So if they are equal, my flag would have been true. So this I've considered for the first type of alternating string. Then I've done the same thing for S2 as well. So if my flag remains true, my answer would be yes, else my answer would be no. So this was the A and B problem. I'm sure like you would be able to solve this problem. These were the easy problems, I would say. Now let's see the C problem of the contest. This was actually, I would say, a good problem. Good in terms of that, okay, so let's discuss it only. Yep. So let's see the C problem. So there is a table 2 cross n, okay, and you want to repaint the cells, okay. Okay, cool. So what the question is given, that you are given a 2 cross n board kind of a thing, and there are some character red blue colors are given on the board. What you have to do is you have to repaint like this, some blue to red or this red to blue, something kind of that thing, to make the two conditions possible. What the first condition is, the pair that we are choosing, pair should have same color, and B, they share a side, okay. So now let's understand this with an example. Let's suppose my n is equals to 4. So if I draw a board, so my board would something be like this, right? So if I talk about the pairs that I could be possible, either it could be I would have taken this vertical pairs, right? Or I would have taken this kind of a horizontal pairs, this horizontal pair, this horizontal pair, or then this vertical pair. So total number of pairs possible is 1, 2, 3 and 4, and they all share a side, they all share a common side. They are sharing a common side, right? And we need to check whether they are having the same color or not. Like if this would have been a test case, then the answer would have been 0, right? If let's suppose the test case would have been something like this, example, just taking an example as of now, R and B example. So what I would have done is I would have taken this pair has to be same, and this are different. So I would have painted this B to R and this again B to R, and I would have said that I would be needing 2 repaint options. Like this is just an example. So I'm sure that you are able to understand what the problem statement is saying. Now let's understand how we would have approached this problem. Many of you have thought of going with a greedy logic as in just like considering the cases as in there. Let's suppose when n is odd, the possibility would only be that either to take this vertical or take one vertical and rest of as horizontal. Rest of as these horizontal, this horizontal, this horizontal, and this horizontal, right? So this and this, or like the vice versa, taking the last and then horizontal. If you would have done this greedy approach, you have got a wrong answer. Now let's discuss why do we have get those wrong answer. Because there could be the possible pairs as well, like these could also be possible pairs, right? Because we need to divide into n pairs. So let's suppose we are drawing this of a 2 cross 5. There could be a possible pair like this. This is a one pair, this is the second pair, this is the third pair, this and this are the fourth pair, like 1, this has to be 2, this has to be 3, this has to be 4, and this has to be 5. So these 5 pairs could also be possible. I'm not bound to take horizontal only, or this. I'm having two options. Either to take the vertical or take the horizontal. Okay, so we know that greedy approach directly won't be working, like considering all of the cases. Now, what approach would have been come to our mind? Okay, so if we talk about that, what approach would have come to our mind is, now here I've written there are two possible options. Now when we dealing with options, is there anything that clicks to our mind? Isn't that, if we are dealing with options, so isn't that DP thing that actually comes to our mind, that what if we want to go with a DP solution? Okay, so here a DP state would actually be something like minimum paints, like minimum paint I would be doing till ith column, or means it is simply like what is the minimum number of paints, let's suppose there is also here something. So let's suppose this is some ith, let's suppose this whole thing is painted, this till ith, this whole thing is painted. So this ith, if I would have done DP of I, this would have tell me minimum paint I have done till the ith column. Now when I am dealing with I plus 1th and I plus 2nd, just let's deal with I plus 1 only. So when I am dealing with I plus 1, what options do I have? If I am dealing with I plus 1 and I have considered a vertical pair, then I would simply be dependent on DP of I, right? I would have been dependent upon DP of I, and it would simply be that if this pair is the same, then my answer would remain DP of I, else it would be DP of I plus 1. But if I would have chosen a horizontal pair, then I would have been dependent upon DP of I minus 1. I'm talking about DP of I plus 1. So if I would have talking DP of I, it would be I minus 1 and I minus 2. Like this is one state back, this is two state back. So if I'm talking about DP of I plus 1 and I'm considering horizontal pairs, like these pairs I'm considering, this pair and this particular pair, then I would have been then I would have got the answer for DP of I minus 2, and then would have checked whether this and this are same. If both are same, then it would simply be DP of I minus 1. It would simply have been DP of I, else it would be either DP of I minus 1 plus 1 or plus 2 according to the pairs, like what I am coloring. So this is a classical DP problem. Let's see the code as well. So DP of I minimum cost to make the first I column. Now when I consider a vertical column, 5 minus 1, I have calculated the vertical. If the values are same, I would have, like the cost would have been 0, else the cost would have been 1. So it is simply dependent on I minus 1, like I would have taken the minimum. Else if I am taking the horizontal columns, then first horizontal, second horizontal, then I minus 2 plus cost of 1, cost of 2. Then simply DP of n would be my answer. So this is how our C problem would have been done in the contest. Okay, so now here comes the most challenging problem, like a very good problem I would say, D problem. Like it actually took me a lot of time to solve this problem, but I was making some kind of small error, so after that I was able to solve this. So let's discuss this particular D problem, and I want you to pay attention here. Like this is actually a good problem and would clarify a lot of your concepts. Okay, so let's start with the problem statement. I'm sure you have all able to understand the problem statement, but for the sake of simplicity, let's read that once. So you're given a 2 integers n and x. Consider a sequence this. You need to find the number of subsegments containing x, XOR 0, okay. And you need to find this modulo done by this, okay. Yeah. So let's understand what the problem statement is saying. So the problem statement is saying we are given two numbers n and x, and there is a sequence from 1 to n. What we have to do is we have to count all the sequences in which x is there and XOR for that L to R is equal to 0, right? Like let's suppose if I've taken any segment of this 1 to n, x should be a part of this segment, like in this range, and XOR of all of these elements should be 0. Okay, so let's discuss this with an example of n equal to 7 and x. So I'll explain this here as well. So for n equal to 7 and x equal to 6, so if we have taken this particular range 4, 7, x lies in the segment, like 6 is between 4 and 7, 4, 5, 6, 9, and the XOR is 0. So we need to count all of these possible segments which are there and finally do the modulo with this number, and we have to output the count. Okay. To discuss this problem, let's divide this problem into smaller subparts, right? Let's solve each and every part in a small fashion, like in a small chunks, and then we'll combine all of the chunks to solve the complete problem. Let's solve the smaller issues that we are facing in the problem. First issue is, how do we find the XOR between L and R? Like, because L and R tends to 10 raised to power 18, how we could optimally find the XOR? This is the first challenge that we have, right? We are not considering this x as of now. Just find the XOR between L and R. So if you have been following my channel or like have followed XOR videos that I have uploaded previously, subset XORs and all, you would have at least solved this particular part. So I would recommend you to go through at least the XOR problems of CSCS problem set that I have discussed in my videos. So if I give you a jinx of it, let's suppose we define, okay, so let's define P of I. P of I is XOR of all the elements till I, right? And similar for PL would be XOR of all the elements till L, and similar for R, right? XOR of all the elements till R. Okay. Now if I need to find the XOR between L to R, wouldn't it be simply P of R XOR P of L minus 1? It would have simply been this. If I give you a pictorial representation, let's suppose this is from 0 to R and here is something like L. If this is the XOR has to be PR and this is the XOR has to be PL, P of L, then this values would simply have been this XOR, this value XOR this, like L minus 1, right? This would have simply been this. Right? So first thing we have understood that how do we find the XOR between, like XOR, easily XOR of prefix XOR, right? Now what they have told is that this XOR should be 0. Now this XOR would only be 0 when prefix of R is equal to prefix of L minus 1. When this both XORs would be equal, then only my XOR of both of them would be equal to 0, right? So here we have solved this first part. Like we can say that like this is actually a very, now have like you will be able to understand that this is something that we can easily find, right? This is something that we can easily find, and in this way we would be able to find all of the XORs which would be having the value XOR is to be 0. We would be further like reducing it, like reducing how do we optimally find this, like or how easily, like this is now something that we can easily solve. Like you might be thinking that yeah, this is the something that I can easily solve rather than this whole of the thing that I was looking at. Okay, now let's reduce it further as well. Okay, now if you would have observed a simple pattern, there is a simple pattern that was there. When my k, assuming there is a k mod 4, my pk would simply be 0. Like when my k, this k was a modulo of 4, like it was getting 0 modulo 4, I'm getting the answer as to be pk, my prefix is 0. When this was 1 mod 4, my pk was equal to 1. Sorry, this was actually equal to k. I'm not, why is it 0? Okay. And when k mod 2 4, my pk was k plus 1, and when this was 3 mod 4, my pk was equal to 0, right? This is a simple observation that we have done, and here I can like I'll just reduce this particular equation as well. So this particular equation I can write as p of j is equals to p of I, where I is belongs to range of 0 till x minus 1 and j belongs to the range of x till n, right? This is a simple equation that we can find out. So like this can, and also this can be k and 0 both, because k would have been 0 over here only. So this is simply like, this is something, okay, just let's see this pattern only, whether this pattern is working or not. Yeah, so let's see also only. So if we take a particular example in the test case, so p of 0 would is 1, and okay, so this would simply be p of 0 is 0 and p of 1 is 1, and so on and so forth. So this would simply be p of k equal to k. Yeah, just yeah, so p of k equal to k. Now till here I think that there would be no doubts, right? You like it would be understand till here. Now the question arises, when would pi is equals to pj? Simply, like when I can say that my pi equal to pj, can I say when my k equal to 0, or it would be something 3 mod 4, my pk is equals to 0, right? And this is the case of 0 I'm talking about, and this is the case of 1s I'm talking about. And when my k is equals to congruent to 1 mod 4, my pk is equals to 1. And I can easily prove that for rest of the values, like these 2s and all of that, when my k equal to congruent to 0 or 2 mod 4, in this case, when you will be solving ahead, you will see that your k would always be increasing, and pi would never be equal to p of j. Only this would be the two possibilities where your pi would be equal to pj, right? So once we have deduced this particular logic. Once we have deduced this particular logic, now what we have to do is we just need to find and calculate all of the possible zeros and ones. So how you would be calculating all of the zeros? If I need to calculate all of the zeros, it would simply be 1 plus. Okay, so let's talk about this. If my n is less than 3, my zeros would simply be 1, else my zeros would have been 1 plus n minus 3 by 4 plus 1, right? Just solve this particular mathematical equation only. You would be able to solve by the pattern only, when you would be seeing the pattern. And when we are counting the ones, it would simply would have been, if n is less than 1, my answer would have been 0. Else, take this is the if condition, else it would have been simply n minus 1 by 4 plus 1, right? So this is how I would be calculating zeros and ones. Now let's dry run our entire logic for a given test case, like n equal to 7 and x equal to 6. Let me dry run the entire logic for this particular case. Let's consider the range between 0 to 5, and this is the left range we are talking about, left range. And here I would be considering like this is from actually 0 to x minus 1, and here it is from x to n. So here it would be 6 to 7. Now when I am talking about this left range and this is the right range, when we are talking about this particular left range, so if I calculate the zeros here, let me explain this particular thing. Let's draw this values. So p of 0 is simply 0, p of 1 is equals to 1, p of 2 is equals to 3, p of 3 is equals to 0, p of 4 was equals to 4, and p of 5 was equals to 1, right? So if we count the zeros, so our zeros, which I will represent something like this, would equal be 2, and if we talk about count of ones, so it would simply be 2. Now let's calculate for the right as well, p of 6 and p of 7. So our p of 7 is simply 0, and p of 6 is p of 5 or 6, so it would have been 7. Yeah. Now if we count the zeros here, so 0 here is, which it would be c of g of 0, it would simply be 1, and ones here would be j of 1, it would have been 0. So now if I need to find the total, what is the total count? It would be simply j of 0 plus c of I of 1 c of j of 1. It would simply would have been 2 of 1 plus 1 into 0. This would have been 2. So, and we can check here as well in the given statement as well. Two segments are possible, 4, 7 and 1, 7. So this is how we are actually solving this problem. So if I show you the code as well, so here is the code as well. So I'm simply taking n and 0, ci0 and cj0. Count of 0 simply be, if n is less than 0, return 0, at 1, and greater than 1, simply this equation. Similar, I counted the ones as well, and when I'm calculating zeros, I'm doing the mod over here, taking the mod so that it does not exceed the integer value, and simply returning the answer. So this is how I've solved this particular problems. Like I was not able to solve E and FG because it was out of the scope of my knowledge. I would be like trying to solve this problem ahead, like I would try to solve these problems, and also would try in the upcoming contest try to solve more of this. And if you like the video, just let me know in the comment section that, because I would be continue posting the solutions for the Codeforces contest which I would be giving. And let me know in the comment section if you have any concerns, any questions, any doubts. and please do subscribe and like the channel for more informative videos.